Hello my dear students, welcome back to another video lesson. In this one, we are going to deal with the most easiest chapter of physics, human eye and colorful world. It's a part of light chapter only. So here there is no numericals at all, is it? Only two you can expect from myopia and hypermetropia. Hope you all done the theory well. So let's go through last 2 years question papers from CBSE in different regions. Let's go for the first question. The lens system of human eye forms an image on a light-sensitive screen, which is called as, see how direct question it is, 2024, the region 1 it is. In human eye, the parts of human eye you studied, starting from cornea to the last optic nerves. In between, the image forms on a light-sensitive screen. It's made up of tissues or cells, we call it as. Two types of cells are there. That screen is called what? Yes, nothing but retina. So options are the cornea, ciliary muscles, optic nerves and retina. Which is the answer? It's retina. Simple. See how you could score the marks. Let's see the next question. Consider the following statements in the context of human eye. So regarding human eye, we have these statements here. The correct statements are, out of these statements, the correct statements you will take it. My dears, always you take care in this type of question. The keyword you should underline. Sometimes they will ask for correct statements. Sometimes they will ask for incorrect statements. So that's very important. So always try to underline this keyword in your question paper. Otherwise, sometime in a hurry, you may miss that, correct or incorrect. Because out of the statements, few will be correct, few will be incorrect. Let's see the statements. First one, the diameter of the eyeball is about 2.3 centimeter. Yeah, that's correct. Our eyeball have size 2.3 centimeter. And that size is also very important. From birth to this one, it never changes. 2.3 is there for normal human eye. If any defect is there, then it may be elongated or shortened. Otherwise, it will be 2.3 centimeter eyeball size. That's correct only. A. B. Iris is a dark muscular diaphragm that controls the size of the pupil. Yeah, of course, that's correct. Pupil and iris, that system is actually to control the amount of light to pass through the eye lens. So pupil has a narrow opening, of course, and its size is controlled by iris to control the intensity of light or how much amount of light should pass through it. That's the iris. So that's also correct only. See, most of the refraction for the light rays entering the eye occurs at the crystalline lens. That's a wrong statement. Because most of this refraction is happening in the cornea itself. The next statement is, while focusing on the objects at different distances, the distance between crystalline lens and the retina is adjusted by ciliary muscles. So distance between crystalline lens and retina, you can't adjust, that's fixed only. So only the duty of ciliary muscle is to change the curvature of the lens. That property or the duty of ciliary muscles. So this statement is wrong and this also wrong. So A and B is correct statements. See the options, A and B, A, B, C, B, C and D, A, C and D is given. So first two statements are correct. So answer is A. It's regarding the functioning of different parts of human eye. See the question came as a MCQ question. So instead of asking direct 3-mark question, explain the function of different parts, they ask it like this way. So be technically fit to answer for these questions. Let's take the next question. The phenomenon of light involved in the formation of a rainbow in the sky are. So rainbow formation, the question is. Rainbow is formed soon after rain if sun shines or sunlight should be there and raindrops there in the atmosphere. So is there, then we'll get the rainbow formation. Okay, so the phenomena, as main or major phenomena is dispersion, So there are 4 steps you can say when the light rays, sunlight passes from air to water drop. Refraction happens and dispersion takes place. Then the other end, total internal reflection happens and it come back. Then again one refraction happens. So refraction is there, dispersion is there and internal reflection also there. So while entering it undergoes refraction dispersion we can say. Then it internally reflects, then again comes out. So here the options check. A. Refraction, dispersion and reflection. Don't go for the answer, read all the statements. Most accurate you have to answer it. You may feel it is correct, but check the second option, refraction, dispersion and total internal reflection. See, B is more accurate than A. Still wait, read others also. See, dispersion, scattering and reflection. No, there is no scattering happens in the rainbow formation. D, dispersion, refraction and internal reflection is given. So the best option will be B is the correct answer. Have you got it? The order also there and the phenomena also, perfect phenomena. So while these questions, of course, read all the options perfect way. So most accurate you have to answer always. Otherwise you will miss the mark. Let's go for the next question. When a beam of white light passes through a region having very fine dust particles, the color of light mainly scattered in that region is, so scattering is regarding. So very fine dust particles are there. So very small dust particles are there. Then when light rays pass through it, scattering takes place. You know what is scattering? The spreading of light or irregular reflection of light rays by interacting with the small particles like dust particles and all. In that one, those colors having least wavelength is scattered more, and those of greater wavelength is scattered less. Or great wavelength colors can be scattered if the size of the particle is larger in compared to the wavelength. So as per the size of the particle and wavelength of the light, based on that the scattering happens. If size is very small, very fine, then only the colors with a less wavelength will scatter. If size of the particle is greater, then the colors with greater wavelength also will scatter. That's the logic behind it. So here, very fine dust particles are there. So, you know, the colors out of this, which you have the least wavelength, red, orange, blue, yellow. Out of this, you know the pattern, VIBGEOR we have violet, indigo, blue, green, yellow, orange, red. Out of this, we have the ascending order of the wavelength. Lambda is increasing from violet to red. So this left side, violet, indigo, blue, has the least wavelengths. All the three will scatter. Out of this, blue is more sensitive to your eyes. So the sky looks like bluish in daytime. It's because of the scattering with the fine particles. So blue, one option. Then red has the greatest wavelength. So red scatters very least in normal atmosphere phenomena. Okay. So in the option here, it's blue is the correct answer. C is the correct answer here. Let's go for the next question. The color of light for which the refractive index of glass is minimum is. Refractive index which is minimum for which of the color? So there wavelength and refractive index, there is a relation. Wavelength and refractive index, they are inversely proportional. If wavelength is greater, refractive index is lesser. So lambda is inversely proportional to wavelength. One relation you can keep in mind. So only in prism, while the white light passes through the prism, it undergoes dispersion. And violet deviates the most, but red deviates the least. It is because violet have least wavelength, but red have greater wavelength. So greater the wavelength, least bending. That bending is least refraction. So refractive index is least. And violet bend the most is because violet have least wavelength. So out of this, red, yellow, green, violet. So here, the color of light for which the refractive index of glass is minimum, then wavelength is greatest. So wavelength is greatest is one, red one. So red is answer, A is the correct answer. If the option is maximum, then it is violet is answer. So that spectrum, VIBGEOR, violet, indigo, blue, green, yellow, orange, red. In that case, violet have the least wavelength and red has the greater wavelength. That you have to keep in mind. Okay? Let's go to the next question. Consider the following statements. The correct statements are, so out of this one, which is the correct statement, again, statement 1, ciliary muscles adjust for changing the intensity of light entering the eye. No, ciliary muscle can't adjust the intensity, but it can adjust only the focal length of the lens only. So 1 is wrong. Only told you, intensity of light entering is controlled by pupil only, iris and pupil setup. Okay, second part. Myopic eye can be corrected by converging lenses of suitable power. No, myopia means what? The person is not able to see the far away objects, or his image forms between lens and the retina, or in front of the retina is formed. So in order to make this image on the retina, it should be diverged. So a diverging lens or a concave lens, the person have to use. So power should be negative. It's not a converging. Converging means convex lens. It's not usable. So second statement also wrong. Third one, the function of the pupil is to regulate the quantity of light entering the eye. Yeah, that's correct. Pupil controls the amount of light passed through it. Fourth, when ciliary muscles are completely relaxed, the focal length of the eye lens is maximum. Yeah, focal length of the lens become maximum when it is thin. Lens is thin, then focal length is maximum. So when ciliary muscle is relaxed, then focal length is greater. This happens when you see an object, far away objects. You know, while watching TV or mobile phone continuously, you have to give rest to the eye. It's not by closing. Just you look to far away objects. So eye lens will be relaxed. So giving rest to eye means giving rest to the ciliary muscles, one way of saying. So like 10 minutes continuously you're watching the monitor. Just in between, just give a break and look at far away objects. Because ciliary muscle get relaxed. Okay, how I got it? So that's also correct only. So third is correct, fourth is correct. So which is option? 1, 2 and 4? No. 1, 2 and 3? No. Third and fourth? Yeah. Third and fourth only the correct statements. So C is the correct answer. Let's go for the next question. Assertion and reason type question it is. Assertion. The rainbow is a natural spectrum of sunlight in the sky. Rainbow is a natural spectrum. Of course, in the sky it forms. Reason. Rainbow is formed in the sky when the sun is overhead and water droplets are also present in air. When sun is overhead, it's not able to possible. Because in rainbow formation, we know the sunlight should come from your behind side and raindrop should be against that, in front of you. Then only we can see it. Is it? Suppose in the morning time, before noon, if you see the rainbow, it will be in western sky. And afternoon, if you see, the rainbow will be in eastern sky because sunlight should have to come from your backside. So here, assertion is correct. Reason is wrong, we can say. So, C is the correct answer, most appropriate. So, overhead, if you say means exact, at 12 noon. It's very hard to find the rainbow because of sunlight. Okay, let's see the next question. Assertion again. Myopic eye cannot see the distant objects distinctly. Yeah, of course. There's a difficulty with the myopic person. Distant vision is not clear. Not distinctly. Reason. For the correction of myopia, converging lenses of appropriate power are prescribed by eye surgeons. See, just previously discussed. Not converging, it is diverging. So here also, reason is wrong, assertion is correct. So option C is correct answer. Assertion is true, but the reason is false. For myopia, diverging concave lens we use, and hypermetropia, we use converging lens. Let's see the next question. Red light signals are used to stop the vehicle on the road. So red light is as a danger signal we use into the road. That's correct. Reason. Red colored light is scattered the most so as to visible from a large distance. No. If it is scattered most, then it won't reach the observer. The driver, it won't reach on the large distance. Red light have greater wavelength, so it scattered the least. Hence, red light is used as a danger signal. It can reach without scattering the far objects. You might remember one other reason for this, like orange lights are used in headlights in fog season or winter season. Why it is? In fog season, big water drops are there. So if you use pure white light, it will be scattered easily. So we won't see the object in the front. But orange light, if you use it now, it has longer wavelength. So it can pass long distance and visibility also greater there. So those who have greater wavelength will undergo least scattering. Okay, so reason is wrong here. Again, C is the answer. Assertion is true, but reason is false. So it is scattered the least. That's the concept. Okay. Let's see the next question. In human eye, the part which allows light to enter into the eye is another simple question. 2023 question it is. So which part allows the light to pass through, enter it? That's the first part. What is that? It's nothing but cornea. This is the answer. So cornea is a membrane. It's a membrane, just transparent membrane should be. If the transparency decreases, then aged people under they feel difficulty to see the objects. Blurred images will be there. Light won't enter in sufficiently. So cornea is a part which allows the light to enter the eye. Now, suppose the question is the part of the eye which controls the amount of light to enter the lens is what? Answer will be pupil. Got it? And retina is what? The light sensitive screen on which image is formed. Then eye lens what? It focuses the image, help to form the image on the retina. Okay. So between pupil and cornea, slight difference only. Cornea is the first membrane which allows the light to enter the eye, the whole eyeball. So first part is cornea. Now pupil is what? It controls the amount to pass through the lens. So after cornea, behind cornea only we are getting this iris and pupil. Next question, let's see. In the following diagram, showing the dispersion of white light by a glass prism, the colors P and Q respectively are. So it's regarding dispersion. You know, white light is entering, it's passed through the prism and deviates, spreads. So P has the greater deviation, Q has the least deviation. Then Q will be which one? The least deviation is for which have greater wavelength. That is red. And greater deviation is for what? Violet. So answer is, see, P and Q is asking. P is red and Q is violet. Option A is the correct answer. The order is very important here. P is violet, Q is red. So P is violet, Q is red. That's the correct answer. B is the correct answer here. See, other option is red and violet, but P is not red. Q is the red. Okay? Least and most deviated. Hope you got it. Let's see the next question. The change in the focal length of eye lens in human beings is caused by the action of. So eye lens, to see the nearby as well as far objects, eye lens, its focal length should be adjusted. That's done by whom? The ciliary muscles. So B is the correct answer. See how the direct questions are coming. Let's see the next question. Assertion. A person suffering from myopia cannot see the distant objects clearly. Yeah, of course. Distant object he cannot see clearly. Reason. A converging lens is used for the correction of myopia as it can form real as well as virtual images of the object placed in front of it. See, a look-like assertion is to be done in another region question. So here it is given. Converging lens again mentioned. Now, myopia we have to use diverging lens. It's because to diverge the rays and to reach on the retina, then only image will be formed. Because in myopic person, the focal length of the eye lens is decreased. To see far away objects, eye lens focal length should be increased. For that, power have to be decreased. Eye lens is a convex lens, positive power. Then in the beginning, in the front of the eye, you have to use a negative power lens, that's concave lens. Hence combined power decrease, focal length increase. The mathematical logic. So myopia we use concave lens. Have you got it? So assertion is true, reason is false. See, all the assertion reason, C is the answer comes here. Got it? Next question, let's see. A person suffering from an eye defect. So he is suffering from eye defect. Uses lenses of power -1 diopter. So -1 diopter means there is a fear to strike the point. It is concave lens. So which is the defect? Myopia. Very good. Name the defect of vision and list its two causes. State the nature of the corrective lens. So it's a 2-mark question. So defect is which one? That is myopia. He cannot see the far objects, distant objects clearly. Now, list its two causes, two reasons you have to find out. So two reasons, many ways you can say. One, the elongation of eyeball. Then second reason, the excessive curvature of the lens. Excessive curvature means actually, if curvature increases, then focal length decreases. So either you can say this one, the focal length of the eye lens decreases than the normal one. So to see the far away objects, the focal length should be maximum. And it should be very thin, the lens should be. Okay. So excessive curvature. Of the lens, eye lens. Two reasons you can say. Or you can say the decrease in focal length or focal length of eye lens decreases. So also you can get it idea. So two reasons you got it. Now one more is there, state the nature of the corrective lens. So nature means is it converging or diverging? So negative is the power. So it's concave lens. Concave lens is what? Diverging will be the concave lens. So it is diverging lens. It is concave. So in lens, concave lens is diverging. Convex lens is converging. Hope you got it? Let's see the next question. What is presbyopia? Name the type of lenses used for the correction of this defect. State the nature, converging or diverging, of the upper part of such lenses. So presbyopia is a defect. We have three defects in this chapter: myopia, hypermetropia, and presbyopia. So myopia, the person cannot see the far objects because his lens loses the ability to increase the focal length, we can say. Or ciliary muscles is not able to increase the focal length. Hypermetropia, another is there. That's because of shortening of eyeball or the image forms behind the retina. That's one idea. Then, or is there, the focal length cannot be decreased, is increased. So far away objects, he can see clearly. Now, by aging, so by birth, there is no defect for a person. By aging, the eye lens and ciliary muscles, their process get deteriorated or the muscles get weakened. So it cannot decrease the focal length after limit. As actually it is hypermetropia only, and this because of the inability of ciliary muscles to reduce the focal length, it's become weakening. That defect is called presbyopia. In aged people it happens. Sometimes both will be there. They cannot see far objects as well as nearby objects. So the defect of human eye, in which the person cannot see the far objects as well as nearby objects because of weakening of the muscles, ciliary muscles, is called presbyopia. So there two concepts are there. One, to see far objects, they have to use concave lens. So by seeing the far objects, the upper part of the lens. So the lens, they have to use it. Bifocal lens, they have to use it. So bifocal means there are two focal lens. Two parts of the lens will be there on the same specs. Upper part and bottom part. While reading and all, or while writing, they need to see the nearby. To correct that one, hypermetropia, and they have to use a convex lens. So convex lens correct the hypermetropia and concave lens correct the myopia. Far distance, concave lens; near distance, convex lens. Hope you got it? So bifocal, how to use it. Now here, which nature is there in upper part? Upper part, you have to cover the distant vision. So that is what? Diverging lens it should be. So upper part we have diverging lens. So upper part, it is diverging lens we have to use it. That is concave. And lower part, it is converging lens, and that is convex. So here, if you distinguish the difference, upper part, it is to correct distant vision. Means myopia. And lower part is to correct the near vision. So to correct near vision, you have to use converging or convex lens. To correct the distant vision, means he is not able to see the far away, you have to use a concave lens. This is a logic approach to this concept, presbyopia. Have you got it? So what is presbyopia? You got it? It is a defect in a human eye in which the person cannot see far away objects as well as nearby objects because of weakening of ciliary muscles. Name the type of lenses used for. It is bifocal lenses. So in that lens, we have both. State the nature, whether it is diverging or converging. The upper part. Upper part is diverging. Lower part is converging. You got it? Let's go to the next question. When do we say that a particular person is suffering from hypermetropia? So what is hypermetropia? That's a concept. List two causes of this defect. Name the type of lens used to correct this defect. So hypermetropia, when you say, it is just one, a person is not able to see the near objects clearly. Distant object he can see. So normal eye, a normal eye have the visibility distinct clearly till 25 centimeter. This person won't have 25 centimeter, maybe more than 25 centimeter, like 50 centimeter, 40 centimeter, maybe like 1 meter or so like. So below 50 centimeter, if you keep anything, they can't see. So to read these things, and they'll keep far away. Distant way they have to keep it. That's the defect of hypermetropia. So if a child feels the difficulty to read book clearly, he may feeling difficulty of hypermetropia. While if a child feeling difficulty to read the whiteboard, he may have the difficulty of myopia because whiteboard is far from him. So to read it clearly, or a faraway boards, writings and all, far things he cannot not able to see. That is myopia. See the practical method of explaining. So what do we say that a particular person is suffering from hypermetropia? So it is hypermetropia, that is the person cannot see the near objects clearly and he can see far objects. So clear vision of near objects is not there with him. That is hypermetropia. List two causes. Causes, of course, the things happen there. In near, this one, birth difficulty may be there, the shortening of eyeball. The shortening of eyeball is one reason. For that, what happens now? The image will form behind the retina. So to see nearby objects, the ciliary muscle have to contract and the curvature increased. Hence, the focal length should be decreased. Focal length of the eye lens should be decreased to see the nearby objects. If not, image will form behind the retina. That's the difficulty with hypermetropia. So, the focal length is getting increased. That's the one other difficulty. So, focal length is too large. Simply we can say it's too large. So focal length of the eye lens increases. Hence, the image forms behind the retina. Now to bring that image on the retina, rays have to be converged. Hence converging lens we have to use. Which lens? Convex lens. So next option, name the type of lens used to correct this defect. So that name is converging lens or concave lens. The converging lens or convex lens is used to correct hypermetropia. Hope you got it? Myopia, concave lens. Hypermetropia, convex lens. Hope you got it? The logic wise you prepared it. Please don't by heart. Next question is, a person suffering from presbyopia. Is suffering from presbyopia. Needs bifocal lens. If he needs two lens of power -4 diopter and +2 diopter. So negative power comes, that is concave lens, positive power given, that is convex lens. Which one of these two lenses is for the correction of distant vision and what is its focal length? So a numerical type question. The beginning I told you, there's numerical if there, then only in the correction question is used to be. Okay, so here, which of these two lenses is for the correction of distant vision? So to correct the distant vision is to clear it, distant object, is myopia. To correct that one, you need a concave lens. Power should be negative. So which lens is used? The power of the -4 diopter for distant vision. Why it is? It is for concave lens. Now, one more question is, sir, what is its focal length? So relation between focal length and power, all of you know it. Power P is equal to 1 by F in meters. SI unit of power is diopter, D we make use of, and then focal length should be in meters. So you have to find the focal length. So F is equal to 1 by P. What is P? It is -4. So it is equal to 1 by -4. So that is equal to negative 0.25 meters. That is 25 centimeters. 1 by 4 is what? 0.25. So negative 2.5, that is negative 25 centimeters is the focal length of the lenses. 0.25 meters. Hope you got it. So hypermetropia and myopia both together is that we call as presbyopia. So distant vision how to clear? Near vision also how to clear. Near vision he need +2 diopter. Distant vision he need -4 diopter. Then we found the focal length also. Next question, let's see. Name the phenomenon of light responsible for Tyndall effect. Write an event where this phenomenon can be observed. So Tyndall effect is regarding. You know, Tyndall effect is the scattering of light with high particles or larger particles. Very fine dust particles, normal scattering happens. If it is of large particles are there, then the scattering is called Tyndall effect. So scattering of light is the concept. The scattering of light is a phenomena which causes for Tyndall effect. Then write an event where this phenomena can be observed. So especially in forest, in fog season, wild forest and all, the canopy, we can say exactly the path of the passage of the light, white light through it. That passage is because of Tyndall effect, we can say. So in forest, winter season, severe winter or fog season, the forest, the canopy we can say, the light passes. That's an example for this Tyndall effect. Direct application we can say. Let's see the next question. What would have been the color of the sky if the earth had no atmosphere? Give reason to justify your answer. So if there is no atmosphere, then color of sky will be dark. You know why? Because sky we see as bluish color. It's because, or white sometimes, is because of scattering of light. So no atmosphere, there will be no scattering happens. So scattering actually the spreading or irregular reflection of light rays while interacting with these atmospheric particles, like gas particles maybe, dust particle maybe, fog particle may be there. So cloud it may be. Like this, if any with particles, if light interacts, then they scatters with respect to their wavelength. If fine particles are there, then bluish color we see it. If large particles are there, or as a whole they scatter, then white color itself you can see. Like clouds are seen white, bigger particles are there. The whole light scattered there. So we see this white. So if there is no atmosphere, the sky looks dark. For astronomers, they see dark only because outer space, there is no atmosphere. So they see dark as the sky. No, it will be white or blue. So if there is no atmosphere, then there is no scattering. No scattering takes place if no atmosphere is there. So concept, give just reason to justify your answer. So color of sky is due to scattering of light. Keep in mind, color of sky is due to scattering of light. Rainbow formation is due to dispersion of light. So don't mix with the concepts. Scattering causes you color of the sky. Rainbow formation, there is no scattering. There it happens, the dispersion and internal reflections we call. Do you clear? Let's go to next question. Study the diagram given below and answer the questions that follow. So one diagram of defect of eye is given. See, n dash, the eye lens is done. If an object is kept at n dash, then the image forms behind the retina. So image is going to behind retina. Which defect is there? You know, it is hypermetropia. If image is formed in front of the retina, that is myopia. So it goes behind the retina. So what are the questions? Name the defect of vision represented in the diagram. Give reason for your answer. So what is the defect there? Yes, it is hypermetropia. What is the reason? Image forms behind the retina. Image is formed behind retina. That's the reason why we are giving it. Now, for your answer, listen. One more reason, if you can say, the focal length of eye lens is greater. So only image is not formed on the retina. As we also can say. So image is formed behind the retina. Now, second part. List two causes of this defect. That's already been done in the previous question. Two causes were shortening of eyeball or focal length of the lens is too large, which cannot be decreased. Okay. Then 3. With the help of a diagram, show how this defect of vision is corrected. So to draw a diagram to show how correction is. So for the correction, you have to use a convex lens. Is it? So how to draw it? Let's see. Eye lens is there. A shortening of eyeball is one of the reasons for the hypermetropia. Near point of normal eye is there. N dash. N is the near point of this hypermetropic person, suppose, as per this question. Then you have to use a convex lens to clear it. So if you keep a convex lens here, it's a correction lens. If an object is kept at N dash, he cannot see it. So if N dash, if an object is kept, it converged by this lens. So it go to pass through this way and convergence happens. Again one more convergence and reach on the retina. So it's a retina. Now what this hypermetropic person will see? He will feel these rays are coming from his near point. What is his near point? N it is. So he may feel it is coming from this way. See the logic? So while practicing, do it with the logic. They'll be fine. So normal near point is N dash 25 centimeter. If you keep the object at 25 centimeter, hypermetropic person cannot see it. It will go behind the retina. So if you keep a convex lens, the result it converges and pass through the eye lens, image is formed on the retina. This hypermetropic eye will feel the rays are coming from his near point N. So he'll see the objects. Have we got the correction? Let's go to the next question. A narrow beam, PQ, of white light is passing through a glass prism, ABC, as shown in the figure. So, ABC is a glass prism it is. A narrow beam of white light is passing through. That's very important. White light and a monochromatic light. Polychromatic and monochromatic. Monochromatic means single color light. Polychromatic means multiple color light. White light is a polychromatic light. And monochromatic means single color, like orange color, blue color, violet color. Like a single color is passing, monochromatic. If monochromatic light passes, only a refraction happens. If polychromatic light passes, then refraction as well as dispersion also takes place. So white light passes, then on this screen D, we get what? The spectrum of white light we get, WebGeor. And then while drawing the figure, violet is the most deviated and red is the least deviated. So the question C, draw a ray diagram to show the emergent beam as it falls on the screen D. Also write the phenomenon involved and its cause. So its cause and what is the phenomena involved. So what is the phenomena? That is dispersion. What is the reason for dispersion? You know, white light is made up of different colors of different wavelengths. So as the wavelength is different, they have different refractive index and they move with the different deviations. So they separate away and dispersion takes place. Once more, each color have different wavelengths. Then they have different angle of deviation, you can say, or refractive index is different. So they bend at different angles and they pass through. That is dispersion. They separate it. That's the reason for dispersion. So we can tabulate as it may. They have different wavelengths. Each color have different wavelengths. Hence, they have different refractive index and they have different angle of deviation. Hence, they separate and move with the different paths. So they splits. That's the cause. Using the second law of refraction, state which color of light must have the highest value of refractive index among 7 visible colors of light. Justify your answer. So from second law of refraction, what is second law of refraction? Sin I by sin R is equal to N2 by N1. You know that equation, Snell's laws of refraction we have. Using that law, you have to show that which color of the light have highest value of refractive index. So highest value means if wavelength is lesser, refractive index is greater. So that equation you have to note down. Let's see how to do it. Sin I by sin R is equal to N2 by N1. And that is equal to V1 by V2. The speed, or say in the medium and in the other medium, first medium and second medium, like that. The same we can express in terms of wavelength also, lambda 1 by lambda 2. Because speed by wavelength is frequency. Frequency will be constant throughout the motion. Hence, V1 by V2 is equal to lambda 1 by lambda 2. So see, if refractive index and wavelength you compare, see they are reverse or inverse proportional. If wavelength is lesser, then refractive index is greater. So it shows that we have lambda 1 is inversely proportional to N1. Is the logic. So here, if wavelength of violet is least, then it have greater refractive index. Hence, the speed will be lesser and it deviates greater angle. That's the concept. If speed is same, then same lines go. If speed is very slow, then go deviated maximum. So we can say violet color deviates the most because lambda V is very less than lambda R of the red. So red have greater wavelength, violet have less wavelength. As wavelength is lesser, more deviation happens. So that question is covered. Now if you draw the figure, it can be like this. Prism is there, incident white light is there, then it's a straight line path. So always take care the refraction dispersion while showing. After entering the class lab, you should draw the straight line path. From there just to deviate it. Never draw above or below. So never it goes to along the line or above it should not go. So it should bend here. That bending is shown there. Refraction happens. Same time dispersion also. So they split and again bend here while emerging out the prism. They bend again and on the form. Here is violet and here is red. So violet we have and red we have on the screen. So as a rough, if you don't have a color sketches, then rough figure you can draw like this way. The prism, white light is passing, then that path you mark as dotted. Then there the first bending happens and splitting also happens. Till there you make the straight line. Then again is bent. So this will be violet, this will be red. This also you can mark it. So while entering from air to prism, one bending, refraction should be there and dispersion also. So from straight line path it deviates. Then again bend as per the wavelength range. Is it clear? Let's see the next question. Define the term power of accommodation of human eye. Write the name of the part of the eye which plays a major role in the process of accommodation and explain what happens when human eye focus nearby objects and distant objects. So it's regarding power of accommodation. So power of accommodation of human eye. See, normal eye lens made up of the tissues only, stretchable tissues, flexible tissues it is. Okay, it can be increase or decrease its focal length in compared to the glass lenses. Glass lenses, its focal length is fixed. But different objects, different image distances are there. But you know, in our human eye, the distance between eye lens and the retina is fixed. You can't change. So image distance is fixed there. So if to see the nearby or far away objects, the focal length of the lens should be changed. You know the equation 1 by f is equal to 1 by v minus 1 by u. This is the lens formula. If v is fixed, then u changes, the focal length will be changing. That's the logic here. So the eye lens focal length is changed by the help of ciliary muscles. So the ability of ciliary muscles to change the focal length of eye lens to see nearby as well as far away objects is called the power of accommodation. So power of accommodation is the ability of eye lens to change its focal length with the help of ciliary muscles. I hope you got it. Now question is that by seeing nearby objects, the object distance is smaller, then focal length also should be smaller. So ciliary muscles contract and the curvature of eye lens increases. Hence, focal length is decreased, image formed on the retina. By seeing far away objects like infinity, the ciliary muscle is relaxed completely and the lens becomes thin. Curvature is very small. Then the focal length is greater, image is formed on the retina. That's the logic behind it. So what is power of accommodation? With the help of ciliary muscles, it happens. Ciliary muscle contract and relax it. And to see nearby objects, focal length should be less because object distance is smaller. So eye lens is thick, curvature is greater, focal length decreases, ciliary muscle contract. To see far away objects like infinity, U is very greater, focal length is also very greater, hence we see the far away objects. Hope it is clear. Pause the video and make sure you are writing each keywords. Let's see the next question. Draw a ray diagram to show the formation of a rainbow in the sky. On this diagram, mark A, where the dispersion of light occurs. B, where the internal reflection of light occurs. And C, where the refraction of light occurs. List two necessary conditions to observe a rainbow. So a rainbow figure, we have to make it. So sunlight should come from your back side of you. One idea. Or opposite side of the raindrops. Soon after rain, sun should shine. So sunlight should be there in air. And proper arrangement should come from behind you. So after rain, sun should shine. One cause or reason you can say. Second, the sunlight should come from your behind of your observer. Then only you can see the rainbow in opposite sky of the sunlight. Then phenomena which happens there, refraction, dispersion, internal reflection also takes place there. So while drawing the figure, you can draw like this way. This is the figure. So white light, this is the sunlight comes in. While entering here, dispersion takes place, also refraction takes place, both. So dispersion is the after effect of refraction, we can say. So there, in the question is given, you have to mark A, where dispersion of light occurs. So here is the dispersion occurs, A. Then it splits and go to the other edge of the raindrop. There, internally reflects, so here C happens. Internal reflection, I'm sorry, it is B. So this is B, it happens. Internal reflection. And where again, while coming out from the raindrop to air, changes the medium, again refraction happens. So while drawing the figure, it's very important. Again, one bending should show. That's very important. So there again refraction happens. So here also you can mention C, no problem, because the refraction as well as dispersion takes place. So actually in detail if you say there are 4 steps, not 3, 4 steps are there. While entering, refraction and dispersion. Then total refraction, third one. Then fourth, again one more refraction while coming out. That way a primary rainbow is formed. So figure is very important. Pause the video and practice it. Show questions. 3 marks easily you can score it. So if you look from here, this is the way. From behind you, sunlight comes. So raindrop is opposite of you. The opposite sky will be. Then come to this yours. After internal refraction only come towards you. So that's the 2 conditions for that. Let's see the next question. Name and explain the phenomenon of light due to which the path of a beam of light becomes visible when it enters a smoke-filled room through a small hole. So through a small hole, if light passes through the room, we can see the path of the light visible. Which phenomenon it is? So to see visible the path of the light means light rays should interact the particles and scatter, spread out. So phenomena is scattering of light. Scattering of light is a phenomena happens. Also state that dependence of color of light will receive on the size of the particle of the medium through which the beam of light passes. So you have to state the dependence of color and the size of the particle. So size of particle is very small. Then colors with less wavelength scatters more. So size of the particle if you mention there, it can be like this way. Very fine dust particles are there. Then colors with a lesser wavelength or least wavelengths. Violet, indigo, blue. They will scatter. Now large particles are there. Like fog particles, water drops, and all. Then we have the colors with a longer wavelengths. Like which one? Orange, yellow, red. Like that, the other end will scatter it. Or if it is very big particles, then as a whole light will scatter, white light will see it. White color. Clouds are seen in white. Why? Clouds are made up of big particles. So the entire light scatter at a time. So we get white color. All the 7 colors mixed together, you get white color, you know it. Okay, so this is about the size of the particles too. So when very fine dust particles are there, we get color with the least wavelength will be scattered. Hence only clear sky looks bluish. If rainy or winter fog seasons are there, then early in the rising time, yellowish or reddish sky you can see. It's because long distance you travel, so only the longer wavelengths only scatters that time. Minimum wavelengths will scatter already, then longer wavelengths also will scatter because of size and distance. Orange, yellow, red. So yellowish or orange mixed color, you see the sky. And because of large particles or long distance it is. So here, state the dependence of color of the light will receive on the size of the particle of the medium. So size of the particle on the medium, this way it depends. See, it's a technical question, logic question it is. Please address it effectively. So keywords are very important there. So pause the video and make sure you know this concept. A probable question it is in this year also. Let's see the next question. Define the term power of accommodation of human eye. So already we done it. What happens to the image distance in the eye? That's very important. So only this question I collected again. What happens to the image distance in the eye when we increase the distance of an object from the eye? So if object changes from eye, the distance, the image distance remains same. Image distance means between lens and retina. See, total eyeball have 2.3 centimeter only. So that size never you can change. Retina is the almost behind part of the eyeball, and lens almost in the front part. So that distance we cannot change. It's fixed only. So here the image distance remains same, constant. So image distance is remaining same. So only the focal length of lens have to be changed to see that object, because object isn't changed, so focal length should be changed to see that one. Name and explain the role of part of human eye responsible for it in this case. So for that, which part is there? We have ciliary muscles. Ciliary muscles are responsible for this part. How is it happening? It relaxes to change the focal length, making the lens thin. It contracts to make the lens thick or curvature more to reduce the focal length. It's called accommodation or power of accommodation. Have we got it? Next question, let's see. What is dispersion of white light? What is dispersion? The splitting of white light while passing through prism-like material is called dispersion. Each phenomena you have keywords. Reflection means what? The bouncing back of light from a surface. What is refraction? The bending of light or deviation of light from straight line path while entering from one medium to another medium. Then dispersion, it is splitting of white light while passing through prism-like material. It's called dispersion. Study its cause. Its cause already done. Different colors have different wavelengths and different refractive index, then speed will be changed and the deviates at different angles. All the causes given in the previous question. Draw a diagram to show the dispersion of beam of white light by a glass prism. So the same diagram you have to draw it. Already made it like this one diagram. You have to keep it. Dispersion. So what is dispersion? That question is separate here. So I kept this question here. The splitting of white light into its component colors while passing through prism-like materials is called so prism it happens, water drops it happens, dispersion. Okay. Next question, let's see. When and where does a rainbow appear in the sky? List the phenomenon of light in proper sequence which occurs during the formation of a rainbow. Why can a rainbow not be seen from the surface of the moon? So 2-3 concepts are here. So first categories, when and where does a rainbow appear in the sky? So when, that's one condition, where is the next condition. So two conditions are there for rainbow. When means soon after rain, if sun shines, very important, because in night sky you can't see the rainbow. So when, soon after rain, sun should shine. Where, always in opposite sky. Opposite sky means sunlight should come from the backside, behind of the observer to see the rainbow. So morning means western sky you can see the rainbow. Afternoon if you see, it should be in eastern sky. That's the idea. Next, list the phenomena of light in proper sequence which occurs during the formation of rainbow. So proper sequence you can say refraction, then dispersion, then total internal reflection, and again one more refraction. So it's the exact way of propagation you can say. Now if you write these three also will be fine, like this three sequence. Dispersion, total reflection, refraction. In the beginning we done one MCQ. In this order is it. See, I told you the order is very important. So dispersion, total reflection, refraction you can say. Actually there is two refraction. While entering the raindrop and while leaving the raindrop also. So only beginning is refraction order. Is that clear? Fine. Now see, one more time is it. Why can a rainbow not be seen from the surface of the moon? So from the surface of moon, if you see the rainbow, actually two conditions weren't possible there. Sunlight should come from behind you and sun should shine after the rain. So in the atmosphere, rain particles should be there. That's because of this dust particle and all, rain particles are, then it's happening. Okay? Next question. It is observed that the power of an eye to see nearby objects as well as far off objects diminishes with age. So it is observed that it diminishes. So ability or accommodation decreases. Ciliary muscles weakens. Give reason for this above statement. So what is the reason for that? The weakening of ciliary muscles. So the first answer is weakening of ciliary muscles. That's the reason. Lens will be there, retina will be there, every part is there. But ciliary muscle is not able to change the focal length. That's the weakening of ciliary muscles. 2. Name the defect that is likely to arise in the eyes in such a condition. So by aging, if it happens, then we call it as presbyopia. Presbyopia. Myopia is there, by birth it can be, or this concept. Hypermetropia is also there. If ciliary muscle weakens and both problems are there, we call it as presbyopia. Normally in aged people it's same. 3. Draw a label diagram to show the type of corrective lenses used for restoring the vision of such an eye. So label diagram, if you draw it. So here, the power of eye to see nearby objects as well as for far off objects is given. So normal for that, 2 diagrams you have to show, which is the myopia correction and hypermetropia correction. That's the way. So such defects, distant vision to clear, that is concave lens. Near distance to clear, near vision to clear, you have to use convex lens. So that 2 figures you have to draw there. So already we shown that figure there, so copy that same diagram here also. Got it? So myopia and hypermetropia, that 2 figures separate you have to draw. Distant clear, how to vision? So this lens is used, which one? Bifocal lens are there. Is it? So bifocal means what? Both concave and convex. So that specs have both parts. Upper part will be concave, lower part will be convex. Let's see the next question. See, it's another same question regarding rainbow. In another set of case, only rainbow and the diagram is asked. So already we discussed in the previous slide. So like this figure you have to make it. Entering the drop, water drop, refraction and dispersion, internal reflection, then again refraction. So the same question is repeating in different cases. Some addition and subtraction, like some points are added, more question, some are little like that. So please be careful on this diagram based questions from this chapter. Next question is, what is scattering of light? Why does the clear sky appear blue? Concept already done in other questions. So one other region, the same question came. Scattering is the spreading or irregular reflection of light rays while interacting with the particles in the atmosphere. So particles like dust you can say, water drops you can say, gas particles you can say. By this particle, if light rays interact, they spread over there or the irregular reflection happens. That's called scattering you can say. So clear sky is seen in blue, we done in blue daytime, the light right, sunlight comes to the sky, atmosphere, then only the least wavelength colors like violet, indigo, blue, they scatters because of shorter distance they have to travel through. So out of this violet, indigo, blue is more visible in this 2-1, sensitive to our eyes, so bluish color sky we see it. Next question. Observe the following diagram and answer the questions following it. So again, one other type of question here. 2023, this question came. See this figure. Light rays coming from infinity. So parallel rays means they're coming from infinity. And see, it is formed in front of the retina, the image comes. So retina is here, eye lens here. Here is the image formed. So in front of the retina, if image forms, what is it? It's myopia. Identify the defect of vision shown. So that is what it is, myopia. List its 2 causes. We already gave that. The elongation of eyeball. So here we have the elongation of eyeball. And the focal length of eye lens decreases. So decrease in focal length. Simple way. Or excessive curvature of lens also you can say. We already explained in the previous slide. So get. Then name the type of lens used for correction. So which lens is used? We use a concave lens you used. So here in this one, a concave lens have to be kept here. So that what happens? The field is far point. From there, it is diverged and pass it. That's a concept. So that figure also, you should clear it really. Okay, fine. Then let's see the next question. The color of sky from the earth appears blue, but from the space it appears black. Why? We discussed already. The color of sky is due to scattering of light. With atmospheric particles. So scattering of light in atmosphere is the reason for color of sky. In earth we have atmosphere. In space there is no atmosphere. No atmosphere means no scattering. So we want to see the path of light. So it should be black. Hence the atmosphere in sky, is black in space. So astronauts see it black. There is no scattering happens. So keyword is scattering of light in atmosphere is the reason for color of the sky. Let's see the next question. Observe the following diagram showing an image formation in an eye. See, another region is asking the same question. See, here the image is formed behind the retina. So identify the defect of vision shown in the figure. Which one it is? It is hypermetropia. We've done it already in another way. So here, second part, list its two causes and suggest a suitable corrective lens to overcome this defect. So two causes we've done. It is shortening of eyeball or increase in focal length of the eye lens. Then how to overcome this defect? We can use which one? A convex lens, we have to use it. We explained in the previous slide, so I hope you could refer it already. So it's repeated in another region, hence we collected this question here. Next question, let's see. What is the least distance of distinct vision and far point of a normal human eye? So least distance of distinct vision is, we write D, and that is 25 centimeter. It is a minimum distance with which normal eye can see the objects without strain. So below that, the ciliary muscles can't contact the eye lens or increase the curvature. So without strain, ciliary muscle can contact this much limit. So that D is called 25 centimeter. And the far point is how much it can relax. It's nothing but far point is infinity. Normal human eye have infinite far point. Maximum distance we can say it. Now, that's first question. 2. A student is unable to see distinctly a chart hanging on the wall of his classroom. Name the defect of vision and he is suffering from, and the type of corrective lens he must use for the spectacles. So a practical oriented question we can say. A chart hanging on a wall will be of course far from him. So far things or distant things he is not able to see. What is that vision? Defect is myopia. So the myopia is a defect he is applying. So blackboard, whiteboard, or the chart or a signboards or the board, name board of a shop, if the student is not able to see, means he cannot see the far object clearly, distinctly. That's the defect is myopia. Then, which lens he should use? Of course, for myopia, which one we have? Concave lens. See, the same concept, different angle, the question is coming. Okay, let's see the next question. Write the main function of each of the following in the human eye. So another set is asked. So human eye, the functions they're asking. Different parts of the human eye, how is working. You know, human eye have different parts. So here they're asking for cornea, iris, retina, and ciliary muscles. The figure, if you say, now to practice the figure, it's not there, but the function is very important. So if you see the function, the first part is cornea. Cornea is a transparent membrane in front of the eye. What do it? It allows the light to enter the eye. So intensity of light, high intensity light also. All the intensity of the light as it is, it's passed to the eye. So it is a window. Cornea allows the light to enter the eye. Next one, iris and pupil. They together work. So iris is a black membrane. Around in between an opening is there. That opening is called a pupil. It controls the amount of eye lens to pass through. So amount of light to pass through it. So it controls the intensity, we can say. So if you see a scorching sunlight, direct, it's harmful to our eye lens, it will damage. So pupil will contrast. Size will be very narrow and least amount of light is allowed to pass through it. So iris will contrast. So least narrow opening will be there. Through that opening, very light, little amount of light only will pass through it. If you see in a dark room, like dim light is if visible, then iris relax, pupil size enlarges. So more amount of light will pass through, he can see the vision. So iris and pupil control the amount of light to be passed through the lens. So proper vision is there. In dark or dim room, it relaxed, size of the pupil increases, more amount of light passes. In intense light, size of pupil will be very less amount of light will be allowed to pass through it. Next one, the aqueous humor. It's a semi-fluid step in between cornea and this lens. So if that fluid actually keep the distance between cornea and the lens. See, in eye lens, there are 4 steps of refraction happens. Most part of the refraction happens while entering cornea itself. These all are transparent membranes only. So cornea itself. Second refraction happens in aqueous humor to keep the distance between this one. Otherwise what happens? Cornea will stick to the lens and proper refraction won't happen. So aqueous humor, a fluid is there. Then crystalline lens we have. Lens is attached with the ciliary muscles. So ciliary muscles adjust the focal length of the lens to see nearby as well as far away objects. So if the object distance changes, then the ciliary muscle changes the thickness of the lens. So different lengths we get it. Then we have retina here, the behind it, we have retina. Retina is a light sensitive cells made up of, there the image forms. Colored image or dark and intense light, also images forms on the retina. Then from the retina, the signals are passed to optic nerves. So optic nerves, it connected with the brain, the part of the vision is controlled. So the image formed retina is converted to electric pulses and passed through the optic nerve to the brain. Then we see the objects. Then in between lens and retina, we have vitreous humor. It's another fluid to keep the size of the eyeball for the proper refraction. If vitreous humor is not there, it will collapse and no proper image formation happens. So both the fluids are very important to keep the size and the distance between these parts for the proper image formation. It's a total working of the human eye. So instead of draw and explain, different parts may be asked. What's the actual role of that one? You should be clear about it. My dears, hope you got it. In another video we'll meet again. Please watch this video thoroughly. Pause the video wherever you want. Prepare your short notes and do your best. Best of luck for your examinations. See you in another video. Thank you for watching.